Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize all numbers as being part of the number system, how to determine which number set within the number system a number belongs, how to recognize that numbers can belong to multiple number sets at the same time, and how to recognize closure of number sets within the number system under mathematical operations. How are we learning it? Through the infinite set closure part 1 notes and the infinite set closure part 1 assignment. When can we use this? To perform simple calculations such as a budget by recognizing boundaries of numbers to determine if adding the items in the budget will stay within your income amount. How do we know we learned it? By getting a score of 4 on the infinite set closure part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria while you fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. After that, we'll go over the infinite set closure part 1 notes, and then I'll give you time to complete the infinite set closure part 1 assignment on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Reasoning with Integers study guide and any incomplete assignments that you may have. Let's take a look now at the infinite set closure part 1 notes. So we begin with our learning goals and success criteria. Now let's talk about the definition of infinite set closure. First of all, what does infinite mean? Infinite means an uncountable number of elements. So it goes on to infinity. It keeps going forever. So an example of this would be like the natural numbers. So we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we can keep counting. And no matter what number we stop at, there's always a number past it. So that's an infinite number of elements. Therefore, an infinite set means that we cannot count the number of elements in the set. The opposite of this would be a finite set in which there are a countable number of elements. So let's say I wanted the natural numbers between 1 and 10. Well, that goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and stops, and we can't keep going. So that would be a finite set. So an example of an infinite set would be the set of integers. So there's no limit to the number of integers we can count. Now, closure definition. What does closure mean? Closure under an operation means a set is considered to be closed if when that operation is performed on any two elements within the set, the result is also in the set. Okay, note that this must be true for all elements in the set. If there is even one case where the result falls outside the set, then it is considered to be not closed. Okay, so let's take a look at what this means. So here's an example. We have the set of -1, 0, and 1, and want to know, is it closed under addition? So what that means is I'm going to take each of these elements, so like -1 and 1, and when I add them together, I get 0, which is in the set. So that means that the set might be closed. If for some reason, though, I end up adding two numbers together and the result is outside the set, so let's say I add something together and I get 6. Well, 6 is not in the set, so therefore it is not closed. So an example of what would make the set closed would be -1 plus 1 equals 0. Because 0 is in the set, it looks like it might be closed. Now, is there an example we can come up with that makes it out of the set? Well, if we add 1 plus 1, because we do need to include it plus itself, so 1 plus 1 equals 2. Well, 2 is not in the set, therefore the set is not closed. And again, if there's even one example of this, so it doesn't matter that this part ended up inside the set. Because this one example is out of the set, then the whole set is not closed. So now let's take a look at this infinite set here, the set S of integers, and what we want to know is it closed under addition. Now we can't use a table anymore, so we need to think of some examples of addition of integers and then try to broaden it and say, is there any way that any two integers can be added together and not be an integer? So we do some examples here, and we can see that they're still turning out to be integers. So is there any way we can add two integers together and not get an integer? So if I add any two negative integers, is there any way to get a fraction out of it? Is there any way to get a real number out of it? Is there any way to get a complex number out of it? Well, No, there's not, right? Anytime I add any two whole numbers together, I should get another whole number. So therefore, there is no way to add two integers together without getting another integer, so therefore the set is closed. Now what about this? The set S of integers closed under division. So again, we're going to think of some examples. So we have 2 divided by 1, 1 divided by 2. Notice here though, when we do 1 divided by 2, we get 1/2. Well, 1/2 is not an integer, that's a rational number. So therefore, when we do it that way, we know that it's not closed. Now, there's an easier way for us to be able to tell that this set is not closed. Because I told you last time, if we include 0 in the set, then it is never closed under division because it's undefined. So if we divide something by 0, it will always be undefined. So 0 is an integer, so if we were to divide a set by 0, it would be undefined. So therefore, that previous set would not be closed because of division by 0. Now, what if we said the set of rationals excluding 0 is closed under division? Well, again, we're going to think of some examples. So we have 1/2 divided by 1/4 is equal to 2, and negative 1/2 divided by 1/3. Remember, really, it's just multiplying by the reciprocal. So is there any way we're going to get something other than a rational number, other than a fraction? Well, we keep thinking of some examples, and when we keep looking, we can see that there is no way. And we did exclude 0, so we know that 0 is not an issue, so we don't have to worry about dividing by 0. So therefore, we can just look at these examples and continue to come up with more examples, and we can see that the set is actually closed because no matter what, when I divide two fractions by each other, I will always get another fraction. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click Start the Activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's talk now about how to complete the Infinite Set Closure Part 1 assignment. So if you look at the top of the page, we have our learning goals and success criteria here. If you scroll down, there's a link here that takes us to the Desmos activity. So we're going to go ahead and click on that. And when we do that, we have it takes us to the Desmos page. We're going to go ahead and click Start the Activity. We have our learning goals and success criteria here. We're going to go ahead and click Next. We have a little intro video, so you can watch this video.
You're not having fun, are you?
No, I am. But only because for the last hour and a half I've been playing the movie Diner in my head.
Oh, look at me. Look at me. Oh, well, I'm on a date with a really great guy. All I can think about is Ross and his cat and his Julie. I just want to get over him. God, why can't I do that?
Oy. Look, I've been through a divorce. Trust me, you're gonna be fine. You just can't see it now because you haven't had any closure.
No! Closure. That's what it is. That's what I need. God, you're brilliant. Why didn't I think of that? How do I get that?
Well, there's no one way, really. It's just, whatever it takes so that you can finally say to him, I'm over you.
Over you. That's what it is. Closure. Oh. Hello. Excuse me. Excuse me. Hello.
Hang on.
Hello. Excuse me. Hi.
What?
Hi. I'm sorry. I need to borrow your phone for just 1 minute.
I'm talking.
I can see that. Just one phone call. I'll be very quick. I'll even pay for it myself. Okay, you're being a little weird about your phone.
All right. Fine. I'll call you back.
Thank you. Okay. Machine. Just waiting for the beep.
Good.
Ross! Hi, it's Rachel. I'm just calling to say that everything's fine. And I'm really happy for you and your cat. Who, by the way, I think you should name Michael. And you see there, I'm thinking of names, so obviously I am over you. I am over you. And that, my friend, is what they call closure. I'm sorry, I don't know. I feel like I had a dream about you last night, but I don't remember.
Okay. Oh.
Did we speak on the phone last night? Did you call me?
No, I stayed at Julie's last night.
Huh.
Oh, actually, I haven't even been home yet. Do you mind if I check my messages?
Oh, yeah, go ahead.
Rach, I got a message from you. Who's Michael?
Oh, my God. Oh, my God, Ross, no, hang up the phone. Give me the phone, Ross. Give me the phone. Give me the phone. Give me the phone.
You're over me?
Oh, God.
What? You're,
Oh, God.
You're over me?
Oh, God.
When were you under me?
Now let's take a look at the actual activity. So the first question says set S integers is closed under addition. And we need to decide if that's true or not. Well, we're going to think about all possibilities. So any two integers, so 2 and 4 for instance. Is there any way I can add any two integers together and get something that's not an integer? And we know that there's not any way to get any number that's not an integer, so that is a closed set. Now when it says justify your answer, you're only going to justify if it's not closed. Let's take a look at an example here. So for instance, this one, S is the integers, and it's closed under division. We know that's not true. And the reason we know it's not true is because it didn't exclude 0. So anytime we divide by 0, we get an undefined number. So we can say because 5, and we'll go ahead and put this like this. So 5 divided by 0 is equal to undefined. So that's how this works. So we're going to go ahead and decide whether it's closed or not. And if it's not closed, we need to provide an example of when it's not closed. So we'll do that for each of these. Then we'll move on. Now here's a bunch of other ones. So now we're just talking positive even integers. And we're talking all odd integers. And so on. So we'll do all this. Then we get to this one. Now for this one's a little different because it says all numbers of the form 3n plus 2, where n is a natural number. So that means, for instance, if I plug 1 in for n, that's 3 times 1 plus 2 is 5. So I'm just going to kind of make a little note of what the set looks like. So 5, if I plug 2 in for n, that's 3 times 2 is 6, plus 2 is 8, and then 3 times 3 is 9, plus 2 is 11. So you can see it starts at 5, and then it's adding by 3 each time. It wants to know, is this closed under multiplication? So if I keep this going, so for instance, 5 times 8. 5 times 8 is 40. If I keep this going, will I end up getting there? So 20, 23, 26, 29, 32, 35, 38, 41. So 41 is not included, so therefore this set would not be closed. So you'll do that for each of these. And then at the end, there's a little closing video that you can watch.
you tell us how you solved the case?
Yes. Well, it all started when I was giving a speech on my new book, and I really think the Velmster should take it from here.
Through the combined intuitive powers of Mystery Inc., we've discovered that the real villain behind this mystery is in fact Scrappy Cornelius Dew, who sadly was corrupted by the power of the Damon-ritis.
Oh, get over it! So I got a little cranky.
Gee, Scraps, no reason to freak out like a jerk and try to kill all humanity.
I would have gotten away with it, too, if not for your meddling son of...
Now that Mystery Inc. is back together, do you have any comment on the Mudbog Ghoul who's been terrorizing London?
Whatever the case, Mr. Ink will be there.
Solving mysteries, man.
Righting wrongs, looking for clues, and kicking butt.
And that is how you complete the Infinite Set Closure Part 1 assignment.